How will humans colonize the stars beyond our own solar system? Research in space travel has only recently begun to tackle this problem. But almost 100 years ago, Albert Einstein made some revolutionary claims about the types of challenges that await those who travel at high speeds across the cosmos, particularly with regards to the way they experience time. While most people view time as a constant, Einstein's special theory of relativity proved that the passage of time is affected by how fast an object moves relative to its surroundings. The faster one travels through space, the more one's perception of time changes. This phenomenon is called time dilation. If an astronaut can travel at close to the speed of light, time will pass much more slowly for her. When she returns to Earth, her friends will have aged more than she has. For example, if near light-speed travel were possible, an astronaut could travel to Alpha Centauri, our closest neighboring star system, 4.37 light-years away. Moving at 99.1% of the speed of light, it would take 8.82 years to get there and back, as measured by an Earth observer. However, due to time dilation, the astronaut would experience a round-trip journey of just over 1 year. Einstein also theorized that the speed of light represented a fundamental speed limit in the physical world. According to Einstein's theory, objects with mass cannot exceed the speed of light, because they would require an infinite amount of energy to do so. This is true for everything from spaceships to neutrinos. In spite of this limit, scientists continue to ponder the possibilities of faster-than-light travel. The first example of faster-than-light speeds in popular culture occurred in the television series Star Trek. On the show, spaceships generated a fictional subspace bubble by surrounding themselves in a warp field in order to exceed the speed of light without experiencing relativistic effects like time dilation. Using this technology, the Starship Enterprise was able to travel billions of kilometers in a matter of seconds. For those of us hoping to seek out new life and new civilizations, scientists have hypothesized that interstellar travelers could be detected. In space, photons can cause drag, and because a fast-moving spaceship would encounter so many more photons than a ship moving slowly, the ship would generate an energy signature that would be both visible in the infrared spectrum and detectable by us. This means that alien civilizations, if they exist, would also be able to detect us traveling at this near-light speed. Outside of science fiction, the fastest we've ever flown in space was during the Apollo 10 mission, which reached speeds of about 39,897 kilometers per hour. At that speed, it would take 165,000 years to reach the nearest star system. This suggests that with conventional propulsion technology, humanity will never reach even nearby stars. The problem with current spacecraft technology is that the propellant they carry with them and use for thrust has mass. Interstellar spacecraft require a lot of propellant, which makes them heavy, which requires more propellant, making them heavier, and so on. However, some of physics' brightest minds, including Stephen Hawking, believe that new technologies are making interstellar travel a real possibility. In the latest initiative launched by the Breakthrough Prize Foundation, Hawking and his team pledged $100 million to send tiny ships to our closest neighboring star system, Alpha Centauri. They claim that lasers are now advanced enough to help launch interstellar space probes. Researchers can currently build phased laser arrays. These arrays are made up of many relatively modest laser amplifiers that can sync up to act like a single powerful laser. Kind of like the Death Star laser, but not all death-like. Eventually, the scientists want to build a 50 to 70 gigawatt laser array that is 10 kilometers by 10 kilometers in size. Launched into orbit around Earth, the array could shoot light at a very small spacecraft, about the size of a saltine cracker and the weight of a paperclip, that's equipped with a 1-meter wide sail. The scientists calculate that this would accelerate the tiny probe to more than 25% of the speed of light after about 10 minutes of illumination. At that rate, it could reach Mars in 30 minutes and Alpha Centauri in about 20 years. The laser array could launch roughly 40,000 relativistic wafer-sized probes per year, carrying sensors, cameras, communications devices, power, and other systems. Some challenges remain. It would take the same array about 2,200 years to propel a fully loaded space shuttle to Alpha Centauri. A much larger array would be needed for a human interstellar trip in the distant future. But with the emergence of these new propulsion technologies, galactic travel might be closer than we previously anticipated. Thanks for watching. Want more Thought Cafe and popular science? Click to watch our last collaboration and make sure to subscribe so you never miss a new video.